Hello, grade 12. Here's another short video on nomenclature of aldehydes and ketones. And I'm going to end it at that for the time being. I'm going to share screen. So same file as last time, except further down in the file, beyond alcohols and the phenols part of alcohols, you'll find aldehydes and ketones. Let me flip to tablet mode so I can write. Excuse me. Yes, tablet mode. Let's choose green ink again. Okay, yes, there we go. So aldehydes and ketones are obviously organic compounds that are characterized. They are characterized by the presence of one or more carbonyl groups. So both contain carbonyl, C-A-R-B-O-N-Y-L, not carboxyl for carboxylic acid. This is carbonyl, carbonyl groups. So a C, carbon that is double bonded to an oxygen, and that same carbon has single bonds to other carbons on either side. Okay, so C double bond O, either represented vertically or horizontally like this, carbonyl groups. A group, one group, or more groups, plural. And an aldehyde has a carbonyl group, C double bond O, okay, at the end of a chain or a branch. At the end of a chain or branch. Sorry, I'm a little bit flummy. I didn't take my allergy pills today. At the end of a chain or branch. And a ketone also has a carbonyl group, but embedded within the chain, okay, in the middle of a chain or branch. Okay, and aldehydes and ketones are both higher priority. Aldehydes are higher priority than ketones. This is lower priority than aldehydes as a functional group, lower. When you're choosing the parent chain or the naming the parent chain, this lower priority. But both are higher priority than alcohols. Excuse me. Choose an alternate over here. Let's choose black. So I can flip back and forth. Whoops. Oh boy. Hasn't done that for a little while. Okay, so I realized that these, when I looked at this a few seconds ago, a minute ago, that these examples are not the best to start out with. So I'm going to draw a couple of other structures over here. So let me draw this aldehyde. So 1, 2, 3, 4, 5. So C double bond O at the end. Okay, and this example that I just drew has the highest priority group is the carbonyl group, and it is on the end of the chain. So therefore, you would recognize that this is an aldehyde. So this is carbon number 1, carbon number 2, 3, 4, and 5. If that were an alkane, because it only contains carbon-carbon single bonds, it would be called pentane. And it has one carbonyl group on carbon number 1 on the very right-hand side. So this would be pentane. Replace the E with an Al instead of an Ol. Pentane. Drop the E, replace it with an Al, and this becomes pentanal or pentanol. Okay, and since the Al, the aldehyde, can only go on the end of the chain, there is no other place where it can go. If you flipped it to carbon number 5 would then become carbon number 1. It would still be 1 pentanal. You don't have to put the 1 in the front to indicate the location of the aldehyde functional group. However, if the carbonyl group is in the middle of the chain, so let's say we have a 5 carbon, 1, 2, 3, 4, 5 carbon let me finish that, 5-carbon chain with a carbonyl group on, say, the second carbon. So let's number this, 1, 2, 3, 4, 5. 5-carbon parent chain with the highest priority group and the carbonyl group on carbon number 2. Now we have to specify the location of that highest priority group. The end of the name for a ketone is ONE. So this would be not pentane, it would be pentane. If it were an alkane, pentane. We drop the E and replace it with ONE. So this bit pentane becomes pentanone. ONE ending. Okay, and the location of the ONE, the carbonyl group is on carbon number 2. So 2-pentanone or pentan, 2-ONE. Okay, and either one of those names is acceptable. So what we have over here in our first example, this is where in previous years I'd have a slightly higher level of complexity. Sorry, folks, that you're not getting that, or maybe you're not sorry at all. Highest priority group, well, we have 3 functional groups here. We have the carbonyl group, we have the hydroxyl group, and we have carbon-carbon single bonds. So 3 functional groups present, and of those 3, the carbonyl group takes priority. So this is carbon number 1. Okay, and then the next highest priority group would be the hydroxyl group. Therefore, the parent chain goes in this direction over here. Okay, that means that we have hydroxyl. Let me delete that. Okay, that means that we have a hydroxyl substituent, and we have this 1, 2, 3, 4 carbon substituent over here. So the parent chain has a carbonyl group on carbon number 1. It has on carbon number 2, it has a butyl substituent. So 1, 2, 3, 4 carbon branch. So but1-il is the name of that branch. And then on carbon number 3, we have a 3-hydroxy substituent. Since the hydroxyl is not the highest priority group here, it is referred to as a hydroxy substituent. Let me just delete that little thing there. And carbon number 4 has nothing on it. So this would be a butanal with 2-butyl and a 3-hydroxy. B comes before H alphabetically. So the butyl is written first in the name of the entire compound. So we have a 2-butyl. But1-il is just butyl. 2-butyl. That's not clear. 2-butyl followed by a 3-hydroxy. Why? Because B becomes before H on butanal. Al ending for the aldehyde. Okay. So next one is oh dear, that is a complex branch that I don't want to do with you right now. Okay, so I'm going to yeah, I'm not even sure I want you to know the names of the ketones and the aldehydes as substituents for the time being. So I'm going to say, let's, okay. Well, I suppose let's get rid of one of these. I'm going to, do I have a whiteout here? I don't have a whiteout. Do I have a white color that I can, oh, I do. Beautiful. Okay, I'm going to, please don't, okay, excellent. Oh, good. So let's pretend that that's not there. Okay, let's delete that. Okay, let's delete that right there. Okay, now I think we're good. Okay, so let's go back to that. Okay, and now let's identify the parent chain as the longest string of carbons that contains the highest priority group, or groups plural. So we have 2 carbonyl groups. So this is carbon number 1. Oh, I didn't change. Apparently I didn't change back. That I need a green over here. Okay, green, and I would like a yellow highlighter. Okay, carbon number 1, and then this goes all the way to the last carbon over here. And since we have a branch right over here, I've deleted the carbonyl group from that branch since that complicates life for you guys. This would be carbon number 1 over here because the branch is closer to it. Carbon number 2, branch on carbon number 3, and then 4, 5, and then we have another carbonyl group on carbon number 6. Okay, so this branch has 1, 2, 3, 4, 5. So it is a pentyl group on carbon number 3, a 3-pentyl. Okay, and then on carbon number 1 is designated as the primary, as the carbon that contains the highest priority group, which is equivalent to the highest priority group in carbon number 6, but one of them takes the end of the name of the parent chain. So this would be the highest priority group over here, part of the parent chain, and then this would be a substituent, a 6. And when an aldehyde is a substituent or a ketone is a substituent, it is called an oxo group. So we have a 6-oxo group, and this is the name of aldehyde. That's ALD, or a ketone, as substituents. Okay, 6-oxo aldehyde. And then we have an oxo O on carbon number 6, pentyl P, carbon number 3. O comes before P, so the full name would be 6-oxo. For this compound would be 6-oxo, followed by a 3-pentyl. O before P. And then we have 6 carbons, so hexane with an AL ending, hexanal. AL ending, that means we have an aldehyde on carbon number 1. Okay, it's as simple as that. Okay, next one. Okay, we have multiple functional groups. We have a carbonyl group over here on carbon number 2, not the end. So that is that is going to be closer to the carbon number 1, so that is going to be our primary functional group over here. This one over here, so this is going to be carbon number 1 on the right. We have, after carbon number 3, we have an alkene, carbon-carbon double bond on carbon number, so this is 1, 2, 3, 4. On carbon number 5, we have a 5-oxo group. And then this is carbon number 6, 7, and this is carbon number 8. Okay, on carbon number 8, we have an 8-hydroxy. 8-hydroxy. So the highest priority group is the ketone group on carbon number 2 on an 8-carbon chain. So this is an octanone, an octan 2-one, octan 2-one. Okay, that means the ketone group in the parent chain is on carbon number 2. And we have a 5-oxo. We have a ketone on carbon number 5. Oh, and then we have, after carbon number 3, we have a 3-En. Okay, and that actually has to go inside the parent chain. Replaces this. Over here, the AN. The AN for ane gets replaced by EN for ene in the parent chain, and there is also a 3 there, indicating the location of the double bond, and an 8-hydroxy. So we have a hydroxy substituent, an oxo substituent, and then an ene. The hydroxy and the oxo go in front of the name of the parent chain, those substituents. And the ene is the double bond. The indicator for the double bonds, double and triple bonds, always go inside the name. They're embedded within the name of the parent chain. So H comes before O. So 8-hydroxy is written first, 8-hydroxy. And then 5-oxo. And then the name of the parent chain, which contains the indicator for the double bond after carbon number 3. So oct. And then -3-En, and then -2-ONE. Okay, so this, oh, I didn't do that very nicely. So, okay, this indicates carbon-carbon double bond after C number 3, carbon number 3. Okay, and this over here indicates, okay, C double bond O, okay, at C number 2, carbon number 2. Okay, so that's the name of that compound. That would be considered a very complex one for all of you in your time frame. I likely would not ask you something that complex with so many functional groups within the same molecule. But that would be par for the course. That would be considered an easy molecule in previous years. Okay, let's identify the parent chain in the last one. Okay, so we see a C double bond O over here, and then this chain over here. So this is carbon number 1. Oops, no. So this is carbon number 1, 2, 3, 4, 5, and then this is carbon number 6. And then you see that we have an OH over here attached to carbon number 1. Whenever you have an OH attached to the same carbon, carbon number 1, same end carbon as a carbonyl group, in fact, it is not a separate substituent. This whole thing over here is a carboxylic acid group. C double bond O, OH is a carboxyl. C double bond O, OH is a carboxyl group. Okay, okay, and indicates the presence not of an aldehyde. Okay, so it's not an aldehyde. It's not an alcohol. Okay, it is, or indicates the presence of a carboxylic acid. It is a carboxylic acid. Okay, and I just want to differentiate between aldehydes, ketones, and carboxylic acids. And that's the end of this little video on aldehydes and ketones. I'm going to stop the share over here and go back to regular mode and save this as a video. And then maybe make another video on carboxylic acids if I have a moment to do that. Okay, I will be back later. I'll see you with some more nomenclature.